So now we have a problem here. This is on determining the flow of liquid. To characterize the flow of liquid, is it streamline flow, is it turbulent flow, what kind of flow is it? So let us have a look at it. As you can see, the question says, this is from NCERT, it says that the rate of flow of water from a tap of diameter 1.25 centimeter is 0.48 liter per minute. The coefficient of viscosity of water is 1 millipoisili, or we can also call this poise. Or in another way of expressing this, someone pronouncing this is maybe a little difficult, so we can always say like this: 10 to the power minus 3 Pascal second. After some time, the flow rate is increased to 3 liter per minute. Give the nature of the fluid flow. So in order to do this, let us first visualize the problem. As you can see, there is a tap and the water is flowing through it. So what is given to us? It is given that the flow of water from a tap of diameter 1.25 centimeter diameter. So if this is the tap here, this diameter is given to us of 1.25 cm. Okay, is 0.48 liter per minute, means the water coming out from here is the volume that is coming out per minute is 0.48 liter per minute. So for example, that our diameter is 1.25 centimeter. The volume that is coming out, which you can call it as, for now let me call it as Q, which is 0.48 liter per minute, because you can see two cases is also given. The second part also says that after some time the flow rate is increased to 3 liter per minute. Give the nature of the fluid flow, means we have to calculate what is the nature of the flow in the first case and what is the nature of the fluid flow in the second case. So let us consider for the first case. For the first case, I am considering Q equal to 0.48 liter per minute. Q will denote it as the volume, rate of volume, volume flowing per unit time. And then what else is provided? Coefficient of viscosity provided, that is this one, 10 to the power minus 3 Pascal second. This is for water, constant. So with this we need to find. So to characterize the nature of the flow of the liquid, we need to know what is the value of Reynolds number. So to determine Reynolds number, the formula for Reynolds number is R equals to rho Vd by eta. So we know rho, we have D has been provided, eta has been provided. What about V? V is not provided. So how can we determine V? To understand V, we see that volume flowing out per minute or per second, volume flowing out per unit time is given as, per unit time is provided to us as Q is going to be volume by time t. Now volume, if this is the diameter of the pipe, this is the water coming out from it, this will be equal to the area, cross-sectional area of this region into the length L, or we can call it X. Therefore the volume should be equal to area into X divided by T. So we can write this also as area into velocity. This is the volume that is coming out per unit time. Therefore from here we can write V is equal to Q by A. So now the Reynolds number can be rewritten as, so we know R is equal to rho Vd by eta. So V would be now equal to, this is V stands for velocity, so rho into Q into diameter D divided by eta into A, area. So again we can further write this as rho Q into D by area into eta. We can write this, the area would be pi d square by 4. So our expression further becomes 4 d1 will get cancelled out, as you can see, this d will get cancelled out. So we'll be left with 4 rho q divided by eta pi d. So our formula reduced formula stands out to be 4 rho q by eta pi d. So using this, if we use the values provided, data provided, we will be able to determine what is the value of R. So for the first case, rho is density of water. By the way, density of water, as we know, it is 1000 kg per meter cube. So we can use these facts now. So for the first case, now we can write R will be equal to 4 into density. Density would be 1000 into Q. Now Q is given to us as 0.48 liter per minute. So what you can do, 0.48 into liter. 1 liter is equal to 10 to the power minus 3 meter cube. So that means this should be equal to 0.48 into 10 to the power minus 3 divided by minus 3. Then we have here Q divided by eta. Eta is again 10 to the power minus 3. 10 to the power minus 3. And one more thing, into pi. Pi will be 3.14 into diameter is 1.25 into 10 to the power minus 2. Centimeter must be converted into meter. Also, if you see here, Q is given to us as 0.48 liter per minute. That means this is actually 0.48 into 10 to the power minus 3 by 60. This gives me seconds. So I must multiply it into 60 as well. So this is our number. So if we solve this one and this one, if we solve this, we will get this around, we'll get this close to, we should get this close to 815. So clearly 815. So this is less than 1000. This one, R is less than 1000. So as you know, between 0 to 2000, the liquid flow is streamlined or laminar flow. So that means R is less than 2000. It is between 0 to 2000 only. That means this is a steady flow. So the flow of liquid in this case would be, the flow of liquid in this case, or the first case, is a steady flow or a streamlined flow. Okay, so if it is between 2000 or 3000, it is going to be unstable flow, but between above 3000, it is going to be completely turbulent flow. So in this case, it is less than 1000. So that means this is, well, it is a very steady flow. Now for the second case. Q is provided to us as how much? Let's see. It is provided as 3 liter per minute. So 3 liter per minute means again 3 liter by minute. That should give me 3 into 10 to the power minus 3 divided by 60. So this one, we're going to use it there once again. So we're going to take R equal to, we have derived the formula here. Formula would be equal to 4 rho Q. So 4 rho Q by eta pi d, or pi eta d. So here again it should be 4 into 1000 into, this time it should be 3 into 10 to the power minus 3 divided by 3.14 into eta, again 10 to the power minus 3 coefficient of viscosity of water into diameter. Diameter again is going to be 1.25 into 10 to the power minus 2 into 60. So that is going to be our, this is going to be the volume. So again, if we solve this one now, it should give us around 5,000, not mistaking, it should be around 5,000, which is, so in this case R equal to 5,000 is very, very greater than 3,000. So this is definitely, now the flow has become turbulent flow. So the flow of fluid is now the flow of the flow of the liquid or water in this case is turbulent. So this is how Reynolds number helps to understand the characteristic of the flow of the fluid. If it is within 0 to 2000, we can say the flow is steady and streamlined flow. But if it is greater than 3000, as in the second case, you can see it is greater than 3000, coming around 5000. So definitely this is a turbulent flow. The irregular flow, the flow of the water coming out from the pipe will be very, very irregular and very, very uncontrolled. Okay, so this is how Reynolds number helps to determine the characteristic of the flow. Hopefully you have been able to understand it. Thank you.